Greetings, today I'm going to discuss how to make military name tags with a desktop CNC machine. I apologize for how amateur this video is and the fact that I'm using PowerPoint for the first half of it, but it helps me organize my thoughts, and hopefully by watching this video you can avoid some of the mistakes that I made. Now, what's the use case for getting this machine? Well, you can make Air Force plastic name tags with it, Air Force metal name tags with it. You can make signage, like little signs to put on your logistics cabinets or desk drawers or signs around your room. You could also make plaques with it, like going away plaques or something like that. Now, none of these materials or projects that you do with this are going to be up to, slick and nice and professionally produced like you would get from a commercial vendor, but you could save a lot of time and money doing this. Now, the plastic and metal name tags, I found for the plastic name tags, it takes about 10 minutes to finish one. For the metal name tags, it's a little longer, 15 to 20 minutes, depending on what you have to do to it. So if you have to make 75 of these during the first part of a semester, be aware it's going to take a long time. Now, I think this is a great machine if especially you need to knock out a couple name tags because one of your cadets lost one, broke one, got it all scratched up, and we all know how difficult it is or how much of a pain it is to get reimbursement for one or two name tags. Like I said, if you had to, let's say you had to make 100 metal name tags in a semester, the cheapest blank ones I found were $3. The cheapest one I found that you can get commercially engraved was like $9, so you save, what, $6 there? So you make 100 name tags, this machine's paid for itself. Now, the machine that I bought was this Genmitsu 318 Pro V2. There's a cheaper version of this, but you have to do a lot more of the assembly work yourself, so I decided to go with this because I didn't want to mess with that. You also want to buy a spoil board, which is like a medium density fiber board, and that prevents damage to your machine if your bit goes through the material that you're working for, if it went all the way through like your metal name tag or something. And plus it raises it up a little bit more and allows you to reach the material with shorter bits. It's only $24. You can make your own if you have a leveling bit. That seems like way too much work for me, so I just bought one of these. It also gives you places to clamp it down because those holes have screws in them there, or threads in them. Of course, after I bought mine, there was a deal on Amazon to buy both for less money than I originally paid, so you can save yourself some money there. You're also going to need some spiral machine bits. I like these. These seem to be working pretty well for me. There's 5 for $24. These are V bits. That's what the Air Force regulations specify that you use to make the name tags. If you want to venture out into making signs and other things, there's other bits you can make, but that's kind of beyond the scope of this video. There's a billion videos and websites dedicated to this hobby that you can go look at. You're also going to need some accessories. You're going to need a pair of digital calipers. I would not go cheap and buy the $10 Harbor Freight ones. Those will just lead to a loss of frustration, so spend a little money, get some decent ones like the ones I got from Home Depot. Again, I'm going to put all these links in the show notes, but you're going to need this to help calibrate your machine. If you don't calibrate your machine, you're going to have some issues that I had, and you're going to waste blank name tags and stuff. You're also going to need small carpenter's bubble level to make sure that your name tag, your blank name tag, is sitting on the machine levelly. Otherwise, it's like I've seen it where it only carves half the letter because it was slanted in one direction or another. So you're going to want to make sure you've got thing level. I'll talk about that more later. Then you're going to need a laptop or a PC to run the CNC software off. Now, Easel is kind of the easiest one to use. You use that in a web browser. There's a pro version that you can get for free if you sign up with an educator's account using your school email address, so go ahead and do that. You're also going to need Carbide Create. It's a free program, and you're going to need this to use the proper font or lettering for the name tag, and then you're going to import that name over into Easel. And then Candle's another free CNC software that you're going to use to help calibrate your machine. I would also note that once you create a project in Easel or one of those other programs, you can actually put it on a little micro SD card and put it in the controller that comes with the machine. That's the black computer thing here that's sitting to the right of the machine in the picture, and you can not have the machine hooked up to a computer at all, so it could be in another room entirely if that's what you need to put. If that's like you want to put somewhere where you don't mind getting like wood shavings or something everywhere. But I haven't played with that, so I'm not sure exactly how to use that, but that is an option. I would note that several people I found online said that the little SD card that the machine comes with that has the software on it has a virus on it, so I would highly recommend that you download the software from a website. Okay, as far as the supplies you're going to need, from Gravur Store USA, Gravotech, they had this engravers and enamel paint that they said conforms to specifications. In fact, I had the specifications for all the name tags on there. I'll talk about that in a second. It's kind of expensive, but that half pint I think would last you several hundred name tags. I'll have links to all this, but there's a place I found that had some pretty cheap blanks you can buy. There's also stencil film you can put on especially the middle name tag to protect it from the clamps, and then it'll engrave through that, and you just paint over it, peel it off, and you're done. Then you're going to need this font. This lettering is free. You can download it with the link I'm going to provide, and that's the correct lettering or font per the U.S. Air Force specification for the name tags. Okay, you might want to write these down. These are the specifications from the Air Force name tag that I found on the Gravotech USA website, as well as some contract solicitations. So this is basically how big the lettering and how big the name tags are supposed to be, and to what depth the engraving is supposed to be done at. Now, when I measured several different name tags using my caliper, they don't exactly conform to this, especially the letter height, but this is basically the specifications and the widths and all that stuff that you're going to need for this project. Okay, after you get your font downloaded, you're going to want to install that, and this is for Windows PCs. So you're going to basically double click on it or unzip it. You're going to click on the font and then click up here to install, and that will allow you to use it in any program that you have installed on your computer, like Word or whatever, or the CNC programs. Then you're going to open up Carbide Create. You're going to click on text, and then you're going to type in your name, and you're going to select the Gravur condensed font. I wouldn't play around with any of this, you're going to change anyways, and then you're going to export to selected items, which is the name. Okay, so now you've got it exported, so now you can close Carbide Create. That's all we're going to use Carbide Create for. Okay, now we're going to open easel, and I've already got some that I've been working on, so I'm going to open up this metal name tag project that I've created. I'm going to go over here. The default, they don't have brass in there. I added it, but you can basically just select aluminum or some other metal in there. It doesn't really matter. The machine's not going to care what you have in there, really. And then you're going to put in the dimensions which I previously provided to you, and that will create your workspace. So you can see it over here. Now we got to import the name. The other thing you need to do is make sure you switch over to millimeters down here. So that's inches, millimeters. So we're going to click over here, got your SVG, and you're going to import the name. Once the name's imported, you go to edit, centered to material, so it's all centered up. Now, the reason we use Carbide Create and we import the lettering is I haven't been able to figure out how to change or import that custom font into easel. Maybe there's a way to do it. Maybe somebody can tell us in the comments, but I haven't been able to figure it out. So that's why we have to have this extra step to make sure we have the font in accordance with the U.S. Air Force specification. Now, if you look over at the metal thing, that's not how a name tag is supposed to look because the cut's set wrong. So the first thing you're going to do is change the cut. So the cut path should be set to clear out a pocket. And now you can see it's set to cut all the way through the material, which is not what we want. So we're going to set it something like 0.3, which I found is a good starting point. And as you can see, this needs to be adjusted. So you can press Shift and select out these areas that you don't want carved. And now it looks like a proper name tag. Of course, you can see that the lettering is too big. Now, in the past, I tried to use this size on here to size it, and it makes it too small, so I find it's easier to eyeball. So the first thing you want to do is click on this. That will lock your proportion, and then move this down to the bottom of the material there. Zoom in, and then you're just going to resize it so that it is 6.35 millimeters taller. You have to eyeball it. So 1, 2, 3, 4, 5. So it's going to be halfway down. So basically you're going to resize it. So 1, 2, 3, 4, 5, 6, 7. So it still needs to be a little smaller. Okay, and then we go back to center the material. And now we've got it correct, so it's 6.5 and it's centered up. So now we're ready to go on to the next step. Okay, I'm going to show you how to set up your machine, attach it to the computer so that you can use it with easel. So you're going to go to machine. I already have one set up, but I'm going to set up a new one. So you click on this. The Genmitsu is under third-party machines. Click on that. It's SandSmart, so you click on that. And then the nearest model that's closest to the one you have, if you bought the same machine I did, is this one. So you click on that, confirm settings. Then you're going to need to confirm your COM port. So that's what we're going to use Candle for. So we'll open up Candle here. Give it a few seconds here. Okay, Candle. Once you've got Candle open, you go to Service, Settings, click on where it says Port, pull down COM5. That should be the port that you need. So you type that in. Okay, so once you get that set up, so we're going to set up a new machine here, so click on that. So you're going to test your wiring. So make sure you have nothing in the way on your machine that while you're moving the spindle around could break. So you're basically going to make sure it's up and down, and then if that's working correctly, you press this, and then your X, which is going horizontally back and forth. Test both directions. Okay, X is working, and then Y is going back and forth, like to and from you. Okay, so all those are working, so you know get a machine. The spindle control, you can just leave that to automatic for right now. Click on spindle. Now you're going to turn the spindle on, so again, you need to make sure there's nothing when this spindle starts moving that could damage anything, and definitely don't have your hands or anything near that. Okay, so it's on, turn it off. Okay, now we're going to check the homing for the machine. So again, make sure you have everything out of the way so it's not going to get messed up. And basically, homing is going to move the bed all the way back and the spindle all the way to the left. So make sure that you have everything out of the way so nothing gets caught. And again, this is like to help calibrate the machine so it knows exactly where it's at. And whenever you start carving and stuff, you're going to do this homing sequence every time to basically recalibrate the machine. Okay, now we're going to set up the Z probe. So we're going to say yes, we have Z probe. The Z probe is this little blue, the blue puck with the metal circle on it with the little clip. And make sure you have that attached. So in this case, it's showing that we already have it lead in there. And we're going to attach the clip. Then once we got that, we're going to physically pick up the puck and just touch it, and it'll, oops. And you're going to see that that light will change from blue to red once you touch it. That forms the contact there. Oops, and I got a clip on. Clips attached to that. And now we do this. There we go. So for advanced settings, this is a very, very important step that is easy to miss because it's under advanced settings. And if you don't do this, it's going to cause you a lot of problems that I had to learn the hard way. So basically what you need to do is for this touch plate thickness, that's the default setting. That's how it comes from the factory.
your touch plate, your Z-probe thing, is a different measurement than what's in there. So that's where you need to get out your calipers and measure it. Probably, measure a dozen times and then average it, and then put that in here so that it knows how tall your Z-probe and the puck actually is. If you don't do this, then your Z-axis is going to be off, and it will either carve too deeply or not carve deeply enough, depending on what cut settings you're using, and it will lead to a lot of frustration. So I didn't set this, and the first time I was trying to carve a plastic name tag, it was just barely literally just scratching the surface and not actually carving. So make sure you set this, go ahead and measure it and set this in here. Okay, so that's it for basically setting up the machine.
Okay, one other thing you need to do before you start carving on this is we have to reset the 0 of this piece. Now traditionally in default it defaults to using the 0 i.e. where the bit is going to think is the starting point at the lower left corner. That doesn't work. I made several name tags that the name was off, centered either left or right or up or down, and it was driving me crazy. I couldn't figure out how to do that, how to get it centered, until I stumbled across this. So basically what you want to do is come to highlight your name, click on the shape, then click on the center, and then you're going to put 0 in here for both. Okay? And then that's going to put your name tag off the material. So it looks like, man, that's not going to work at all. But trust me, this is how you need to do it. I have several messed up name tags to prove it. And then that's when you're going to basically, on your name tag, you're going to put the film or the tape, or on the plastic one, you just get a fine marker and draw an X on it to center it up, and then measure out that point and make sure it's exactly in the center of your name tag, and that's going to be your work 0. Okay, now we come to the part where you're just going to have to press the I believe button, is setting up the bit. So if you actually went in here and picked out a 60-degree V-bit and put it in here, it would tell you it's going to take something like 17 hours to carve out this name tag. And if you did it like I did, thinking, oh my god, I guess that's the way I got to do it, you would watch the machine carve in like a nanometer at a time, and it takes literally hours. So you basically have to trick the machine. So what you're going to do is you're going to basically make a fake bit in here and use an actual 60-degree V-bit in your machine. So you're going to go to add bit. Here you want to do like a custom bit. So you're going to custom, you're going to name it, and just, I would select like an upcut and make it like 0.5. So upcut, and then just change it to 0.5 millimeters, and just name it something that you can remember. And then you're going to select that. Come down here, so that would be this one. And then notice down here this estimate time. In my experience, has never taken that long. It usually takes like half that amount of time, depending on your cut settings. So in here you got how big your piece is. Here you've put in the fake bit. Trust me, this works. This is going to have to do it. Now, if you want to carve other stuff, like you're making signs, or you want to make like a going away plaque, you want to experiment, there's plenty of other videos that tell you exactly what kind of bits to use and all that, what kind of bits to buy, and how to set all that stuff. So I'm not going to go over that here. The next thing is you want to set up your cut settings. You want to go to manual, and then this is basically what I've used that seems to work pretty well. So you're going to have to balance between, if you run your bit too fast, you'll start getting chatter where like the machine is not powerful enough, it won't cut, it'll wear down your bits quite a bit faster, and it may skip and not cut smoothly. If you don't cut fast enough, then the material will build up, and again that will dull your bits, and it could even start, like in the case of the plastic, name tags could start melting back into the material. So that's so you don't want. So this takes a lot of experimentation. You may find that you have to play with this and you're going to waste a couple blank name tags figuring this out exactly. But these are the settings that have worked pretty decently for me. And this is for the metal name tag. For the plastic name tags, you can run it at higher feed rates, which is how fast it's carving back and forth. The plunge rate, how fast it's pushing into the material, and then the depth per pass is how much is taking off every time it cuts, and then how fast the machine's rotating. And then I just use the offset method here in the vertical. Those seem to work well. Again, you can experiment with that if you'd like, but that's what's worked for me.
Okay, now you need to level your spoil board, so you're going to use your level and check it in both directions, left and right, forward and backward, and you may have to shim it with some paper like I did here, because even after you tighten your spoil board down completely with the screws, it may be off, and then it won't carve evenly. Like I had a name tag where it carved just the bottom half of the name tag, and I had to go back and recarve it at a greater and greater depth. You need to make sure that you tighten your bit down tightly in the collet, which is the conical piece that goes up into the spindle that's held in place with that black nut. So the bit that you put in there should not be protruding up above the collet. It should be down below it so that it has enough to grip on. Right about there. You want to make sure that's not sticking all the way up there so that it has a good grip. But nor do you want to have it down at the very edge of the collet at the bottom so that it doesn't have enough of the bit to grab onto. And then, like I said, make sure you got it down really tight. Now we need to mark our name tag so that we know exactly where the center of the name tag is. So basically you're going to measure corner to corner with a ruler and then draw an X. And this can be done with either the plastic or the metal name tag. And I like to put this tape on there that you see in the drawing here because A, that protects it from being scratched by the metal clamps, plus it makes it easier to paint. I would still recommend doing that with your plastic name tags. Then you're going to go back after the X is drawn and measure up and down and left and right to make sure you have the exact center, and then you're going to draw a dot there so you know exactly where the center of that name tag is so that you can center it up properly on a machine, and therefore the name will end up being centered left and right and up and down. If you don't do that, then it's going to be offset, and then you'll obviously have wasted a blank name tag on that. Now we need to clamp down the name tag. So first you need to make sure that it's perfectly straight or perpendicular in all axes so that the name doesn't get carved on there slanted. So use the lines on the spoil board to help line that up. Put your clamps in. I always do lower right corner, upper left corner, because the bit tends to come over from the left. That way the bit is out of the way and you don't smack it on there. And definitely you want to have tape or something on your name tags to prevent them from getting scratched up by the metal clamps. There's a couple different clamps that come with the kit, including some wing nuts you can use, and you'll just have to see what works for you. But make sure that you have the name tag really tight on there so it can't move, because the bit is going to be putting quite a bit of force on there, and if you don't have it clamped down properly, it's going to move while it's carving and then mess up your name tag, which is what you don't want to do. Now for other things, such as if you want to carve a plaque or something, or a little sign, you can use double-sided tape. That will hold them down. That works well. And there's plenty of other videos you can find on YouTube on how to clamp this down properly. And you can see here, this is kind of why I recommend getting the spoil board, because it does make it easier to clamp down. Especially if you have a short bit, you need it to move the bit up in the Z-axis for the bit to be able to reach down and do it. For the plastic name tags, because they have those pins and they're not flat on the bottom, you're going to have to make yourself a jig out of wood like I did here. So you're going to use your machine to carve out a square and then drill some holes for the pins so that you can get it basically flat. And then you're going to clamp that whole thing to your spoil board. And then you may want to resurface this with a resurfacing bit to make sure that piece of wood is absolutely flat. Otherwise, you're going to have some issues. And here you can see on some name tags you buy, it's burned in and then sometimes it's glued. But in other words, that part and the pins will not allow you to sit flat. Hence, you need a jig.
Okay, we've got everything set up. Our machine's installed. We got the name tag clamped down to the spoil board. We have the name tag set up here. We've got the correct 0 set in here. So now we're going to get ready to start carving. So the first thing we need to notice is if it says up here green, that means the machine is connected and ready to go. So we're going to press on that, click. We're going to confirm the thickness of our material. In this case, it's 0.7 millimeters. So click on that. We have the material clamped down. Material secure. Click on that. Then we're going to use our bit. In this case, I have a 0.3 millimeter. Again, that's the fake bit in the other video. And previously, I think I showed a 0.5. But at any rate, had some discussion on how to do that already. So confirm your bit size. Now we're going to get the zeroing in. So first we need to zero the z-axis with the probe. So click on that. Then you're going to confirm your position. So you need to start moving the z-axis or the y-axis. So first, actually click on here 10 millimeters. I like to work in millimeters. So just click that down. It move over here. So it's roughly over your name tag. So then once you get it roughly in position, click, you got the clip set up, clip is attached. So now you need to put right there. So we got it on top of the name tag, so now we need to lower the bit. I would only do this at 1 because you don't want to damage your bit or your machine. So you put it on 1, click down, and then you're just, once it gets close, you're going to switch over to 0.1 millimeters and keep lowering it until you see the red light, which means it's touching the plate. Okay, so its touch plate is in place. You click on this, go back to a millimeter, raise it up, and then you're going to start probing, and the machine is going to test it again. So now it's zeroed in the z-axis. So I'm going to disconnect the probe, move that out of the way, and now comes the important part for we got to set the XY zero. So you're going to lower your bit down again, get it close but not touching, because if it's touching when you start moving the bit around, then it's going to scratch your name tag, which you don't want. So you're going to basically, you can see here I put on 10, so I went too far. So, oops. So I'm just trying to get it aligned. You have to stand up and look, look closely at it, make sure you don't have any parallax, that it actually is on 0. And you probably have to switch over to 0.1 to actually get it right over the dot that you drew on your name tag. Okay, so once you've got that set, then you're going to put set X and Y 0. Now, this use last 0, you don't want to do that unless you have to go back and recarve into your material. Let's say that it didn't cut to enough depth because like the name tag is not perfectly flat on your spoil board. Then you could go back after it's done, go back, erase whatever letters that were done fine, and then lower the depth like 0.1 or 0.2 millimeters, go through this whole process again, but say use last 0, and you can basically restart it and keep carving on the same name tag, and it's accurate enough that it won't mess it up. So you'll be able to, obviously take you longer, but you should be able to salvage that name tag and get it carved correctly. So, all that being said, set X and Y 0. Now, I like to raise up my spindle a little bit. So we're going to turn on the spindle. So now it's running, spindle's on, yes, and then you would hit carve. So once you hit carve, it's going to start working. You need to be ready to press the red button over here in case it messes up, like it starts hitting your clamps or something, or otherwise goes haywire, like you didn't have this down tight enough, hit that button and it will automatically stop the machine. That's your safety stop. And if you, after you reset it, you're going to have to twist it so that it's like spring loaded, it'll pop back out. And if you don't do that, the machine won't connect while that red button is pressed in.
Okay, now we're watching the machine carve. Yes, it will get noisy, so don't panic. I like to get a vacuum cleaner and vacuum up some of the metal sawdust or plastic sawdust, as it were, every so often. So just keep an eye on it. Obviously, for safety, you shouldn't just walk away from the machine. You keep an eye on it. And now here we can see the metal or the plastic name tag being done. You can see it working on the jig. Notice how it's only carving the bottom half of the letters deeply, and that's because it's not level front to back. So I probably should have shimmed that better. Okay, if that happens to you, you can go back, use the original 0, set the depth lower, and recarve over the letters. However, you can see in this case, like, because it wasn't level front to back, the bottom of the letters are thicker than the top. So make sure you have everything level and you shouldn't have that problem. So that concludes this video. I hope that it was useful. You can see the final product. Again, not perfect, but compared, if you think about this machine costs about $400 with everything together, and the commercial machines cost 10 times that much. I don't think the results are bad. So hopefully this video was useful. And if you have any comments or questions, put them down in the comment section and let me know, and I can update the video if there's significant interest in doing so.